In the first part of this slide series we discussed about terms, usage and applications related to arrays. In this slide series, we will be discussing implementation of arrays in different programming languages, and we will be talking about implementation of arrays in both older and modern programming languages. First we will discuss about arrays in Fortran, which is the first high-level programming language. Fortran was developed by the IBM in 1950s for scientific and engineering applications. Since Fortran was used for scientific applications, it had to find a way to represent vectors and matrices. The solution was arrays. The one-dimensional array corresponds to a vector, while a two-dimensional array corresponds to a matrix. Here we are talking about Fortran 77, rather than early versions of Fortran which had limited facilities when come to arrays. Unlike some of modern languages, Fortran indexes the array elements from 0. Therefore index corresponds to the location. For example, element with index 5 is the fifth element of the array. Fortran 77 supports one-dimensional, two-dimensional, and multi-dimensional arrays. Unlike Fortran 4, which only support up to three-dimensional arrays. The simplest array is the one-dimensional array, which is just a linear sequence of elements, stored consecutively in memory. There are two ways to declare them. Those methods will be discussed in coming slides. If the array holds numerical data, and implicit typing is used, then the dimension statement is all that is necessary. In syntax we have to use dimension keyword followed by any array name and the size within parentheses. If the array is to take a data type, which is contrary to the implicit types, then the array can be declared in the same statement as the type declaration. Look at the examples given in the slide. As mentioned before, by default Fortran arrays are indexed from 1 onwards. Thus in the array of size 20 index of the first element is 1, and the index of the last element is 20. However, we can use arbitrary index ranges for our array as shown in the slide. Matrices are represented using two-dimensional arrays. When declaring two-dimensional array in Fortran, we have to specify both number of rows and columns in the 2D array. Examples show how to create the array, called the uptype real, which has 3 rows and 2 columns. This slide shows the indexes of each element in 2D array of size 3 into 5. If we are using arbitrary indexing for a two-dimensional array, we have to specify starting and ending indexes for both rows and columns. Syntax to be followed is as shown in the slide. Fortran 77 only supports multi-dimensional arrays up to 7 dimensions. All the elements of a particular array should be of same type. That means you cannot have several types of elements in a single array. Each element of array should match the type of the array type declared during array declaration. Multi-dimensional arrays are declared in the same way as one-dimensional arrays. The array bounds or lengths of each dimension are separated by commas. Array elements are stored in contiguous blocks of memory as shown in the slide. Unlike some other programming languages, Fortran stores arrays in column major form. That is to say, the leftmost array index varies the most rapidly, followed by the next leftmost array index, etc. Thus, the last index in an array varies the most slowly. This slide shows what happens in column major form. As we said earlier, when we move from left to right in a two-dimensional array, the value of the left index changes while right index stays the same. Now let's talk about problems with Fortran arrays. Number 1 is, Fortran does not detect out-of-bound array accesses unlike in modern programming languages like Java. Therefore it is the responsibility of the programmer. Second one is that, Fortran does not support dynamic memory allocation, therefore this leads to inefficient memory utilization. Third one is it limits multi-dimensional arrays to 7 dimensions. Pascal is an influential imperative and procedural programming language, designed in 1967 and 8, and published in 1970 by Nicholas Worth as a small and efficient language intended to encourage good programming practices, using structured programming and data structuring. Coming slide we will be talking about the implementation of arrays in Pascal language. Given in the slide is the syntax to be followed in declaring a Pascal array. First we have to declare array name, then it is followed by colon, and keyword array which is followed by square brackets within, which we specify stating index, and the finishing index we desire to have. Then it is followed by the keyword of, and declaration ends with array type followed by semicolon. An array data structure defines the size of the array, and the data type that it will use for storing data. In the previous example, the array stores up to 20 integers, starting from index 1 up to 20.